Okay, this was the problem at the end of class, and I promised to send you out the algebra on the finality of the problem, but I decided I wanted to do the entire problem so that I can have it for the video library. So the first thing you want to do when you're asked to find the area of a region bounded by two curves is to actually draw it. I think it's helpful if you would draw it. So, and we did this in class, and I'm just going to do a rough sketch here. I'm not doing to scale or anything, but because we're going to add some algebra onto this. So we've got two curves, e to the minus 2x, which is a decreasing function. You know, from left to right it falls, and e to the x, of course, is an increasing function. So what I like to do first is to define your f of x and your g of x. And remember that f of x has to be greater than g of x. So in this case, oh, I forgot to add the limits of integration. The one thing that we were given was that this region is bounded on the right by ln of 4. So what remains for us to find is the lower limit of integration. So first let's define f of x and g of x. So f of x is the curve on the top, which is e to the x, and g of x is the curve on the bottom, which is e to the minus tx. Now remember that if you're having difficulty seeing any of that, you can always plug in an x value and find the y's, and whichever one's bigger, that's your bigger function. Shade in this region that we're after here. So the next thing we're going to do is find the lower limit of integration, and to do that we're going to algebraically do it, or you could use your graphing calculator to find the points of intersection. In this case, I equated the functions, which hopefully you remember from your algebra days. To find the point of intersection, you equate them and solve. Alright, so I'm after the lower limit of integration at this point. I'm trying to accumulate all my pieces in order to solve the area problem. So doing that, e to the x equals e to the negative 2x. Take the ln of both sides to unlock the exponents, and you get x equaling negative 2x, and the only point that happens is when x equals 0. So that's your lower limit of integration. So let's build the integral now. It goes from 0 to ln of 4 e to the x minus, right? Remember that we're doing f of x minus g of x for area between two curves. And the second function of the g of x is e to the negative 2x. So this just boils down to finding the antiderivative and evaluating it. Hopefully, and we did review this in class, hopefully you understand that this piece you need to use substitution. Okay, you need to use substitution. Let u equal negative 2x, right, which would be du is equal to negative 2 dx. Substituting in, sorry about that, my scroll's not working too well. Substituting in, you get negative e to the u du, du over negative 2, so that's just equal to 1/2 e to the u. Okay, so substituting that back in, u equaling negative 2x, you get this antiderivative, and you need to evaluate that between 0 and ln of 4. So substitute in an ln of 4. Minus, sorry, I'm running out of space here, e to the 0 plus 1/2 e to the 0. Right, and of course, e to the 0 is just 1. So that term, hopefully you understand, or you recall your logarithm and exponential rules. So that's just 4 plus, I'm going to hold on to this for a minute, 1/2 e to the ln of 4. I'm going to move that constant multiplier up as an argument. And again, another log rule. So that's ln of 4 e to the ln of 4 raised to the minus 2 power, and this is 3/2. So algebraically resolving this term, let me grab another color, this term reduces down to 1/2, and that is just 1/4, right? The negative exponent squared minus 3/2. So fractionally finding a common denominator, you come down to the final answer of 81/30 seconds. Okay, hope that helps.